My name is Tanaya. My register number is ORK24AI1077. Today I'll be explaining about the experiment number 5, performance analysis classification techniques. So our aim is to demonstrate the performance metrics for the tree-based classification techniques used in data science applications. So K-nearest neighbors KNN algorithm is type of supervised ML algorithm which can be used for both classification as well as regression predictive problems. However, it is mainly used for classification predictive problems in industry. So, so the working of KM algorithm is this algorithm uses feature similarity to predict the values of new data points, which further seems that the new data point will be assigned a value based on how closely it matches the points in the training set. We can understand its working with the help of the following steps. So step one is for implementing any algorithm, we need dataset. So during the first step of KNN, load the training as well as the test data. Step two, choose the value of K, that is the nearest data point. K can be any integer. Step three, for each point in the test data to the following. Calculate the distance between test data and each row of training data with the help of any of the method, namely. Uh, and now, based on the distance value, sort them in ascending order. Next, it will choose the top k rows from the sorted array. Now, it will assign a class to test point based on most frequent class of the rows. Step four is the end. So the performance metrics is for classification problems. Various performance metrics that can be used to evaluate predictions for classification problems given below. First one is confusion matrix. It is the easiest way to measure the performance of a classification problem where the output can be of two or more type of classes. A confusion matrix is nothing but a table with two dimensions that is actual and predicted. Furthermore, both the dimensions have true positives, true negatives, and false positives and false negatives. So the other is classification accuracy. It is the most common performance metric for classification algorithm. It may be defined as the number of correct predictions made as the ratio of all predictions made. So the accuracy is calculated as TP plus TN. As we said, TP is true positive and TN is true negative, and divided by TP plus FP plus FN plus TN. Okay, so the next is classification report. This report consists of the scores of predictions, report, F1 and support. They are precision used in document retrievals may be defined as the number of correct documents returned by classification models. So the equation for precision is TP by TP plus F. For recall may be defined as the number of positives returned by classification model. It can be calculated from the confusion matrix. Recall is equal to TP by plus Fn. And specificity, in contrast to recall, will be defined as the number of negatives returned classification model. So the equation for specificity is Tn by Tn plus Fp. Okay, so now I'll be explaining the question. So the first question is implement the KNN classification for the given data set and analyze the performance of the classifier. So the program is import numpy as np and import pandas as pd, import matplotlib as plt from sklearn model, import train test split, import linear regression, import mean squared error to store. Okay. Yeah. So first we do is load the data set and we give the file data so we can load the data load the data set first, and next will be the feature and target selection. Yeah, so here we predict the amount based on the box. So X is the data set of boxes shipped values, and Y will be the data set of amount values. So next we do is we split the data set 80% train and 20% test. So X-train and X-test, Y-train, Y-test is equal to train test split XY, test size is equal to 0.2, random state is 42. And we know, of course, like if take a set of data, like there will be some anomalies in the data set. So for that, we have taken only 42. Next is like we create and train the linear regression model. So we use this linear regression function model dot fit X train and Y train, and then we make the prediction. So Y prediction is model dot predict X test. Then we do is the performance matrices. Yeah, we give the mean squared error Y test and Y predict. R2 is equal to R2 dot score Y test and Y predict. So then we print the coefficient slope of it, and next we do is model dot coefficient of 0. Then we print and we give the model of intercept and we print the value. And next we do is visualization. Yeah, we use scatter plot for the visualization, and we plot it and we give the conditions we needed, and yeah, this is the output for the plot. And yeah, the result, the KN classifier was successfully implemented using the iris dataset. The model achieved an accuracy of approximately 96.7%, showing strong classification performance with high precision and recall for all classes. Thank you.